Hi everyone. So today again we are going to see PYQs on loop and arrays, okay, which are related to cache. So yesterday we have solved some good universities questions. Some good questions from top universities. Now let's just see PYQs. And before that, I think one of the question I have given as an homework. So let's just spend some time in solving this. Okay. So what they're saying, you are given the following code to analyze. So as you can see, this is a 2D array, right? Okay. Now maybe I can go to the next page and let's just see what they're asking. They are saying that if cache is direct mapped and total block size is this and cache block size is this, total cache size is this and block size is this, then what is the miss rate? Let's just find out. So if this code is given to you, then it is also given in this question that size of integer is 4 and array start at the memory location 0, right? Which means that that it is a block aligned, which means that if this is a block, then array start from here. Okay, array start from the very first boundary of the block. The boundary of the block. It's not the case that array is starting from here, which means the first element of array x00 is not in between of the block. Okay, it is starting at the boundary of the block. Okay, so because array is starting at 0 and which means at 0 address, which means if this is main memory, then that's how we do the division of the blocks, right? So if array is starting from here, it means it is starting from very first, like you can say the boundary of the block, right? Okay, and suppose instead of this, let's suppose they say that array started this address. Maybe if they say array started this address, then can you check whether it is a boundary of block or not? Can anyone tell me how to check whether this address, if array is starting from this address, then it is a boundary of block or not? Let's suppose block size is 8 bytes. Okay, let's suppose block size is 8 bytes. Then can you tell me that this address will be start of the any block address or not? If array is starting from this address, is this starting also from the block boundary? Which means this address is, if this is a block some block, then this address is basically some between of the block, or this is a beginning of any block. Can you tell me how to check quickly? It's easy, right? See, if the block is 8 bytes, then you know that block boundary will be either 0, block will be starting at 0, address 0, or maybe 8 or 16 and so on, right? So basically we just need to check that the block, if the block size is 8 bytes, then the block boundaries are 0, 8, 16 and 32, sorry, not 32, 24 and 32 and so on, right? It is multiple of 8. The given address, we just need to check quickly whether it is multiple of 8 or not. Can you check extremely quickly whether it is multiple of 8 or not? In binary, things are extremely easy, right? How to check this address is multiple of 8 or not? Can anyone tell me? Okay, see, you just need to check last 2 power 3, right? This is, you just need to check last 3 bits, right? Last 3 bits here, in fact, last 4 bits and last even 8 bits are 0. So if the last 3 bits are 0, it means it is a multiple of 8, right? Since it is a multiple of 8, so it is a starting, like you can say it is a start address of any block. Understood? Okay. In binary, things become very convenient, right? I hope you understood that this is a multiple of 8 because the last 3 bits are 0. That's why it is a multiple of 8. The given address was the multiple of 8, right? Okay. If you want, I can also write it. So see here. Okay, just a second. Let me just remove this. Okay. So here, what I'm saying is that suppose if I want to check given address, let's suppose given address is, suppose it is 0xff100. Okay. Is this address multiple of 8? Is this address starting of any block? Address of some block if block size is, let's suppose it is 2 power 3 bytes. Okay. Then what is the answer? Yes, because last three bits are 0, 0. Hence, given address is multiple of it, right? Right. Hence, given address is multiple of 8. Okay. Now let's just see this question. What they're saying is that this address is starting from 0 and you are using LRU and so on. Okay. So let's just see that how to solve this question. Okay. This is having 1, 2, 3, 4, 5, 6 parts. Okay. If let's just solve the first question where the cache size is given to be 2 power 9 bytes, right? Which means they are saying that there are how many blocks? 2 power 9 divided by 2 power 4. It means you can say 2 power 5 blocks. Okay. And now, since the block size is 16 byte, can you tell me block size is 16 bytes? It means the how many element it can have? 4 elements, right? Each block can have 4 elements. Okay. Now, what they're asking next is that what is the miss rate? Can you tell me how does the array look like in memory? It is x 0, 0, x 0, 1, right? And so on. Okay. Now they are accessing two elements, right? They are accessing in one iteration, they are accessing two elements. One is x00, another one is x10. Okay. So one is x00 and there is a lot of, elements between x00 and x10. Cool. So one is x00, another one is x10. Now they are asking that what is the miss rate? So let me go to the next page. Maybe I can just copy this loop. Okay. Let's just copy this loop. Now, see, they are saying that you are x00 and then x10 and so on, right? Okay. So first you are accessing. By the way, which one you are accessing first? X00 or x10? What do you think? Which one you are accessing? Yeah, most probably 00, but it doesn't matter because it will be converted to assembly, right? It will be converted to assembly, and whichever is having first, maybe let's suppose you are saying that R1 is storing R1 register may store this 0 or something, so it will be load. So maybe load R1 is having first, or maybe load R2 is having first, but there will be consistency, right? Because this will be converted to assembly at the end of the day, and then either you are accessing this first or this first, it doesn't matter. Okay, so there will be some consistency whether if you are accessing this first, then is this the case that for I equal to 0 you are accessing this first, then for next I equal to 1 you are accessing this first? No, right? It will be consistent. If you're accessing this first, then you are accessing this first. Why? Because it will be converted to assembly, right? Maybe this load R1 is having first, or maybe load R2 from this particular memory location, which is x10. Maybe this is first, right? It doesn't matter, but there will be consistency because that will be converted to assembly, right, at the end of the day. Okay, so see here that what they're saying, that x00 is getting stored, and then x01 will get stored, and then so on and so forth. So how many elements this x0 has? I think 128 elements, right? So from 0 to 127, right? From 0 to 127. Okay, total 128 elements this x0 has. Similarly, there will be x1 also. So maybe I can just copy this one only. Okay, so now you have x1 also. So that's how the array look in the main memory. Okay, hope you understood that how does array is looking like in the main memory. Now let's just see that a block is containing how many elements of the array and so on, right? So as we can see that a block is basically having 4 elements, right? So that's why you will say that some 4 elements you will be having. Okay, some 4 elements you will be having, right? This is one block. Can you tell me the block number? The block number will be 0, right? Okay. Now there will be some other block. Can you tell me the block number for this particular X10? Can you tell me the block number here? See how many elements are in between. How many elements? 128 elements, right? 128 elements. If each block is containing 4 elements, then how many blocks are these? How many blocks are these? 128 divided by 4, which is 32. 32 blocks, right? So these are 128 elements. So you can say in other words, these are 32 blocks, which means 0 to 31, right? Which means 0 to 31. Now, can you tell me what is the block number for this? I mean, this particular block number, can you tell me? This is block number 32, right? This is the block number 32. This is the block number 31. And then this will be the block number last block. Can you tell me? There will be again 32 blocks. So 0 to 63. I think there will be total 64 blocks, right? Okay. Is this understood to everyone? These are the block numbers, right? I have just written the block numbers. Now let's just see that what they are saying. Okay. So maybe I can just remove this. They are saying that first you access X00 and in the same iteration, you are accessing X10 also, right? You are accessing X00. So which means you are accessing this block and then you are accessing this block. So by the way, can you tell me the access pattern in terms of the block? Access pattern. Which block you are accessing? 0 and then 32. Is this okay to everyone? Right? Okay. This is basically when I equal to 0. Then when I equal to 1, then at that time, can you tell me at I equal to 1 what is happening? At I equal to 1, what will happen? Same, right? Same. Great. 0 and 32. Because here, this is again, you are going to access this element and this element. So this will be same actually, right? 0 and 32. Now, for I equal to, so basically this is 1 iteration, 2 iteration, and then 3 iteration, and then 4 iterations, right? Then for 4 iterations, I think this will be same. Because 4 elements are in one block, right? For I think 4 iteration, it will be 0, 32. 3, 4. Can you tell me the next iteration? It will be, what is the block number? For the next iteration, then you will be accessing this, right? This particular element, which is in 1, and then here maybe this particular element, then 1 and 33, right? 1 and 33. Okay. Anyway, this is basically, I am saying this is the access pattern of block. I mean, that's how you are accessing the blocks, right? Blocks of main memory. What is the size of cache? Size of cache is given to us is 2 power 5 blocks, 32 blocks. Okay. So they are saying that you have 32 blocks in the cache. Right? 32 blocks. Okay. So till now, we have just seen what is the access pattern, right? I mean, how you are accessing, which block you are accessing. And then we have seen that how does array look like, right? Cool. Now you tell me, on this 0, it will be mapping to which block number in the cache for this 0? 0, right? And for this 32? 0 again. So if you're putting this, then immediately you're saying, after you're putting this, immediately you're saying you vacate it and now you're going to put it. So see, initially it was miss, right? Initially it will be miss. So for this it is a miss, and then again for this is a miss. Now you again access this. Will it be hit or miss? What do you think? It will be again miss, isn't it? So it will be basically miss on every element, right? Because you are just using one of the line. So it is miss on every element. So what is the miss percentage? Hence, miss rate is 100%, right? 100%. Understood? Okay, let's just see the answer. So for this, it is 100%, right? Okay. And just, I hope you understood, right? And in this question, if I say that if we are increasing the cache size, let's suppose in this question, okay, then will it help you? What do you think? If you increase the cache size, Let's suppose, okay, for now, let's suppose if I decrease it, let's suppose instead of 32, I have 16 blocks. Will it help you? This 16 blocks? No, right? Because again, it will be mapping to 0. It will be again mapping to 0. So 16 won't help you, or maybe in other words, from 16, even if you have 32, it doesn't help you, right? Okay. What about 8? Even if you keep 8, it is again same miss rate. What about if you keep 64? Then probably it will help, right? Because if you keep 64, it will map to 0. It will map to 32. So 0 and 32. Then maybe for every 2 element, you will be getting, you can say if the array is having, okay, how many elements? 4 elements, right? Okay, so it will be, I think for every 4 element, there will be one miss only, right? Okay, if the cache size is 64 blocks, maybe that's the next question, I think, right? Yeah. So they are saying that if you're doubling it up, if you're doubling the cache size, then how this is helping you? The miss rate is basically getting half, getting 1/3, or what it is happening. If you're, so part B, okay, this is the part B. Cache size is, let's suppose, cache size is how much? 64 blocks, right? And your access pattern is same, okay? Access pattern of main memory blocks, it is same, which means it is 0, 0, 32, 0, 32, 0, 32. Okay. So now you tell me, if this is, 1, 2, 3, 4 times you have 0, 32, and then 133 and so on, right? So 4 times you have 0, 32, and then 133 and so on. Okay. So now you tell me, how much is the miss rate? What will happen now? Can anyone tell me? What is the miss rate? See, a block is containing 4 elements, right? So once you store this block, this will be stored in 0, and this will be stored in 32. If there are total 64 blocks, right? Okay. So maybe I can just tell you with the example of the diagram. So there are how many total blocks here in this particular case? There are 64 total blocks, right? Okay. If there are 64 total blocks, then what is happening? You are saying that one block is containing 4 elements. Okay. This is containing 4 elements. So you are mapping this to 0. You are mapping this to 32 now. Okay. Why 32? Because total blocks are 64 blocks. 64 blocks. Then these are 4 elements here, right? These are the 4 elements. Don't forget about it. These are the 4 elements. Then if you're accessing this one, it will get stored in 0. This one will get stored in 32. Then for next 3, it will be hit only, right? For next 3, it will be hit. So what is the miss rate then? Out of 4, you are basically saying that you are missing only on 1, right? So that's why it is 1/4, right? This is 1/4. Okay. For part B. Let's just see part C. Let's just see the part C. Now they're saying it is two-way set associative. 512 bytes is the cache size, and 16 bytes is your like the cache block. Okay. So I think this particular thing and this particular thing is same. The only difference is that it is now two-way set associative. So instead of direct map, okay, if the cache size and everything is same, instead of direct map, they are saying now it is two-way, which means they are saying that again the one block is containing 4 elements. Okay. So 1 element, 2 element, maybe I can write it x00 from x03. Okay, one element is containing 4 elements, one block is containing 4 elements, and then there will be x10, x2, x13. Okay. And how many total blocks we have? This array is basically having 64 blocks, right? 64 blocks. Anyway. Okay. So you are saying that now it is two-way set associative, 32 lines only, right? 32 lines, but 16 sets. Okay. So if you are, let's suppose accessing this block number 0, this is block number 32, then what will happen? This block number 0 will be mapping to set number. Can you tell me set number 0? This will mapping to set number 0, right? Set number 0 again. Why? Because yeah, set number 0, because there are 16 sets, right? Since there are 16 sets, so it will be again mapped to the set number 0. Is this okay to everyone? Now, since it is two-way set associative, okay, each set can contain 2 lines. So now this is there, this is also there. Now, whenever you are accessing this next, it is a hit, right? And then 3 hits. So 1 miss, 3 hit, isn't it? Now the block number 1 will be there, and then you will be keeping it there and so on, right? The things will repeat. So again, can you tell me the miss rate here? Can you tell me miss rate? How much we got? It is again 1 by 4. See, here the question number 1 and the question number 3 are same. Okay, the parameters are same. I mean, the cache size and block size is same. The parameter is same. The only difference is that it was direct map. It is two-way set associative. Okay, so just because they made it two-way set associative, and our pattern, I mean, access pattern is such that it was 100% miss rate here, and it is 25% miss rate here. Okay, cool. Now they are saying the things are same. It is again two-way only, but now you, instead of having 16 sets, okay, instead of having 16 sets, this is part C. Now let's do the part D. Instead of having 16 sets, they are saying you're doubling the sets, right? I mean, you're doubling the lines, which means, yeah, you're doubling the sets also, right? So 64 lines, which means 32 sets now. Okay, so this is D. Now let's suppose you have 32 sets. Okay, so what's going to happen here? This is going to get to map to 0. This is again going to get to map to 0, right? So will this be same, or it will be decrease or increase? What do you think? Same, right? Okay, so 1 by 4 is the answer here also, because this will map to 0, this will map to 0, right? And then for the new block, again the things will repeat. For new block, again this will map to 1, this will also map to the 1, right? So it can hold both of them, right? So I think again this is 25%, 25%, right? Okay. Now let's just do this part, which is basically they are saying now that you have 16 sets only. I mean, these parameters are same. So you have, sorry, not same. So maybe I can do one thing. I can just copy this parameter. So basically they are saying this cache size and this cache size is same. It is again two-way set associative, but now the block size, okay, the block size is basically doubled. Cool. So each block can contain how many elements now? 8 elements basically. Okay. I mean, earlier it was containing 4 elements. Now basically they are saying, let me just copy this one, right? Okay. So see, earlier each block was containing 4 elements. Now they are saying the block size is 32 bytes. If it is 32 bytes, it means 8 elements, 8 integers, isn't it? So now each block is containing 8 elements. Okay. So here it is x00 to x07. Okay. So this is 8 element block now. Now we have x0127 and then we have x10. So how many elements we have till this point? 128 elements, isn't it? It means how many blocks we have? 128 divided by 8, because one block is having 8. So basically it is how much? 2 power 7 divided by 2 power 3. I think this is 7 divided by 3. This is 2 power 4, right? Which is 16. Okay. So you have 16 blocks till this point. Can you tell me the block number of this? Block number of this? It means this will be the block number 16. So now your access pattern will look like this. See, now you will say your access pattern will look something like this. Maybe I can do one thing. Let me just, sorry, write things on the same page. So now you will say you are going to access the block number 0 and block number 16, right? Block number 0 and then block number 16. I mean this 0, 0 and 16, and maybe 8 times you will repeat, but that's fine. Now what is the cache size? Cache is having 512 lines. Sorry, 512 bytes of cache, which means 2 power 9 divided by 2 power 5, which means how many lines we have here? 2 power 4 lines we have. 16 lines, which means 8 sets we have. 8 sets. Is this okay, everyone? 8 sets we have. Okay. Now you tell me what is the number here? 8 sets, and each is basically having 2 lines, right? What is the set number here? 0, right? What is the set number here? What is the set number here? For this particular element that we are going to access, the set number is again 0, right? The set number is again 0. But both of them can fit in the main memory. Sorry, in the cache. So what is the miss rate now? For every 8 element, you are having how many miss? For every 8 element, you are having just one miss. So that's why 1 by 8 is the answer, which is 0.125% in terms of percentage, right? I mean 0.125, and in terms of percentage, it is 12.5. Okay. So see, have you understood the steps, that how we are performing the steps? The steps is that how does the array look like in the memory? Okay, how does the array look like in the memory? And what is the block number that we are accessing? 0, 16, right? 0 and then 16. And it is mapping to, this is my 0 will map to 0, 16 will map to 0. And then what is the next thing that we are doing? Again, we are going to access this, which means that out of every 8, we are going to miss only once. Now let's just see the last part, which is they are saying that now it is the cache size is half, okay, and the block size is increased, is doubled. Okay, so now they are saying that each block is now containing how many elements? 64 divided by 4. So each block will contain how many elements now? 16, right? Okay, so you will say each block is having 16 elements. X002, maybe X015. Can anyone tell me what is the block number of X10? What is the block number of this X10? Can anyone tell me? How many elements we have before X10? So this is 16 elements, okay, in one block. How many elements we have before? We have 128 elements divided by 16, which means 2 power 7 divided by 2 power 4, which means 2 power 3, right? So 8 blocks we have, which is 0 to 7. So that's why the block number is 8 here. So we are accessing 0 and 8, okay? And then the cache is looking like this. They are saying you have 2 power 8 bytes of cache, 2 power 6 bytes of blocks. So how many blocks you have? 4 blocks, right? And if it is two-way associative, 4, 1, 2, 3, 4, then 2 sets, set number 0, set number 1. So sets equal to 2, number of sets equal to, okay. So it will be mapping to set 0. It will also map to set 0. But I think fortunately both of them can keep, I mean, both of the blocks can be in the set. So that's why out of 16, how many misses are we going to face? 1 miss. So 1 upon 16 is your answer, right? 1 upon 16 is your answer here. Understood how we are solving all the questions? So 1 upon 16 is your answer, which is half of even this, right? In terms of percentage, it will be 6.125. Okay. So this is really a nice question where we have solved many variations so that you understand that how things are happening. So you understood the steps, right? We have seen that, okay, how does array look in the main memory? one block is containing arrow look in the sense that, okay, one block is containing how many elements and what is the access pattern for us. Okay, we are going to access this block, and what is the next block number we are going to access, right? This is the next block number we are going to access. Okay, this is the next block number. So that's how we are solving this particular question. Okay. So really a nice question, right? I hope you understood. Let me know if there is any doubt here. Even if there is a doubt, I'll just suggest you to take a pause, and if you are seeing it offline, then just spend some time. Okay, maybe you can spend 1 or 2 hours just to solve this question. Okay. By the way, let me just tell you one small story. See, in the gate, there are I think 7 to 8 PYQs of this type, this cache or and loop and these particular analysis. There are 7 to 8 PYQs. Can you guess that in how many days I have solved, like at my time, in how many days I have solved these 8 PYQs? Just related to this. Okay, any random guess? Okay, so basically I was not solving whole day. Let me just tell you, I was just solving in morning session. Okay, I was just solving, okay, not 1 month, 1 month is too much, in 8 PYQs. So I was just solving in morning session. You can say that, okay, 1-2 hours I was just giving for one question. So I think I have taken 8 to 9 days, okay, just to solve these 8 PYQs. Not obviously like complete day. So I can say 1 to 2 hours daily. What happened that I saw these particular question, and I saw that, okay, I don't even know the concept that what is happening, right? And then I struggled a lot. So I thought that, okay, it is giving me too much headache, but still I need to solve these questions. So I decided that I will do one thing. I will take 1 hour daily, okay, or maybe one question daily, basically, which is how much time it is going to take doesn't matter, maybe 1 hour, 2 hour, 3 hour, but I will take one question daily and I will solve it, okay, entirely. So generally it is going to it was taking basically 1 to 2 hours, or maybe sometimes if the question is tough, then 3 hours probably. Okay, but finally I solved these 8 or 9 PYQs in 8 and 9 days, and in the morning session, because I thought that, okay, I will just solve one question and I'm done for the day. I was not even daring to solve more question than I mean more than one question. Okay, so anyway, this was just one thing that I wanted to share. So even if you are going to take, let's suppose, a little longer for these questions, then this is fine. Okay, then this is fine. Maybe you can spend 1 to 2 hours just to solve this particular question. It is definitely worth it. Okay, because I have spent 9 to 10 days just to solve 8 to 9 questions. So maybe you can also spend some time. Okay, that's definitely worth it. And it was even the time of the same time, the November end or something. Okay, it was even the November end when I was solving these kind of questions. Okay, so now let's get started with the PYQs. Okay, let's just see that if we can understand these questions, and if not, then what is the difficulty? Okay, good. Let's just see this question. They are saying a CPU has 32 KB. 32 KB means 2 power 15 bytes is the cache size. This is the cache size, which is a direct mapped cache. And what else they are saying? Now they are saying that you have 128 block size. So block size is also given 2 power 7 bytes. Is two-dimensional array. So array size, right? Array size is also given to us. It is 2 power 9 into 2 power 9 elements. Okay. And each element size is also given, which is 8 bytes. So you can say 2 power 9 into 2 power 9 into 2 power 3 bytes. Right? Consider the following C code. Okay. Now they are saying that P1 and P2 executed independently with the same initial state. Namely, the array A is not in the cache and IJX. Okay, these IJ and X, these variables are in the registers. So you don't need to worry about miss or hit for these variables basically. Let the number of cache misses experienced by P1 is M1 and this is P2. Then you need to find the value of M1. Okay, and for the next question, the value of M2. So maybe I can do one thing. I can just go to the next page and let's just try solving this question, right? So here you need to find the value of M1, which is the miss by this particular loop. Okay, maybe I can just see that what they're saying. They're saying that you are going to access this aij. So how does array look like in the main memory? The block is going to contain how many elements? If 2 power 3 is the size of one element, then how many elements a block can contain? 7 by 2 power 3, it is 2 power 4 elements, right? Is this okay to everyone? 2 power 4 elements. Okay. So which means 16 elements a block can contain. Okay. Anyway, so you are going to say that, okay, from A00 to A015, a block can contain, right? Some block can contain this. Okay. Now, what is the this cache? This cache is basically having how many lines? This is the cache size, this is the block size, which means 2 power 15 divided by 2 power 7. It is 2 power 8 lines, right? It is a direct map cache, and 2 power 8 lines you have here. 2 power 8 lines. Okay. Now, you're accessing in very sequential manner, so let's not worry about anything else. Now you tell me, if you access this, then there will be, I think, one miss out of 16, isn't it? Isn't it? So 1 by 16 seems to the miss rate, but they're not asking the miss rate, they're asking number of misses. So which means what is the total number of elements? You can just multiply with the total number of elements, which is 2 power 9 into 2 power 9, right? These are the total number of elements. I mean, this is the miss rate, and these are the total number of elements. So you will get to know that how many total misses are there. See, 1 by 16 is miss rate, right? So what does this miss rate tell you? It tell you that out of 16 axes, you have one miss, right? Out of 16 axes, you have one miss. So out of one axis, you have 1 upon 16 misses. Out of how many elements axis you are doing? 2 power 9 into 2 power 9 elements you have. So out of these many elements, how many misses you have, right? So that's how you can understand. So 2 power 9 into 2 power 9 elements, if you are going to access, then how many misses that you are going to have? 1 upon 2 power 4 into 2 power 9 into 2 power 9. So it is 2 power, this will be 5, 2 power 14, right? These many misses you have. So whatever is the 2 power 14, you can see. I think most probably C is the answer, right? Okay, 2 power 14. Understood this question? Easy only, right? Easy question. Not very tough question. Okay, because they are accessing sequentially, so you can see that how they are doing. Yeah, there are two questions basically. Okay, in the second question, they are asking for the loop 2. The second question is related to loop 2. Okay, cool. Now, see, this is the second question, which is related to loop 2. So they are saying you find out M2 also, then M1 upon M2 they are asking. This is first question. So they asked two questions in the same paper. This is the question number 81. Earlier was the question number 80. Okay. Anyway, so I have not written all the details here in the 81. There is the previous detail I have just skipped just to make it little shorter screenshot, but the details are same. Okay, let's just find out M2 also. So this is going to be interesting because they are accessing JI. Now, can you tell me how much each block is having? I think each block is having 16 elements, right? So these are 16 elements. And now this is, let's suppose, A00. Can anyone tell me what are the number of elements? What are the number of elements before A10? How many elements these are? This 0 will be ranging A01 and so on. 512 elements, right? So these are, you can say, 512 elements. Now, can you tell me, if this is 2 power 9 elements, then can you tell me how many blocks you have till this point? 2 power 4, which means 2 power 5 blocks we have, isn't it? So we have 2 power 5 blocks. Can anyone tell me the block number here? This is the block number 0. Then what is this block number? This is block number 32. Okay. So they are saying once you are accessing, see, your access pattern is like this, right? Your access pattern is little typical here. You are accessing, you're keeping this I fix. Okay. then you are changing this j, which means you are accessing in this way. Keeping this 0 to be fixed, keeping this I fixed, then you are changing this j, which means you are accessing 0, 0, then 1, 0, then 2, 0, and 3, 0, and so on. Okay. Okay. Not an issue. So what is the very first block you will be accessing? Access pattern, can you anyone write? Access pattern of main memory blocks. Can anyone write? It will be the block number 0. And then can anyone tell me what is the next block number they're accessing? The next block number is 32. And since they're accessing with 32 gap, right? I mean 32 blocks. Now, obviously, the 20 will be again 32 gap because of symmetricity, right? Again, A20 will be out of like it will be 32 blocks away, which means again it will be 64, right? Again it will be 64. So that's how you are accessing. See, you should be knowing that how you are accessing. Then only you can solve these kind of questions. See, if it is sequential access, then not an issue. But if it is that kind of jump of access, right, then you should be knowing that what is the access pattern. Okay. So I hope you understood that this is 0, 32. That's how you are accessing. How many lines you have? 2 power 8 lines, right? Okay. If you have 2 power 8 lines, it will map to what? 2 power 8 lines you have, right? It will map to what? Can anyone tell me? Line number 0. Okay. It will map to what? Line number 32. It will map to 64. And then it will be mapped to 996. Okay. So how many total blocks we have here? We have total 2 power 9 into 2 power 9 elements. Each element, each block is having these many elements. So 2 power 14, right? 2 power 14 blocks. Okay. So we will be keep on accessing 0, 32 till 2 power 14, right? Till 2 power 14. Okay. So, I mean, you will be keep on incrementing. This will be 96. Then it will be, what is the next number? 128. Then it will be 20. Okay. Now, you are accessing this. Now you tell me, whenever you access the next element, whatever this is, by this point in time, are you replacing this particular block from main memory? Which means from the cache, which means if this is mapping to 0, are you replacing? Let me write it. See, are you replacing the cache line 0 by the moment you access this again? This is the cache line 0, which is currently containing 0. Then 32 will contain something. Then 64 will contain something. Then 96 will contain something. And then okay, sorry, 2 power 8 lines means this is 256 lines. Yeah, this is 128. Then again, yeah, there will be 256 block number, right? You will be accessing 256 block number. Tell me, are you going to access this 256 block number or not? See, you are going to access the block number with the gap of 32. So see, let me just go to the next page and let me just try to explain that what I'm saying. See, the very first basically the element you are accessing is A00, and then you are accessing A10, right? So you are accessing something from here. You are accessing something from this particular block, right? See, you are accessing something from this particular block. So you are going to access this 0, the block number 0. Then you are going to access something from this particular block, which is block number 32. Then again 64, then 96, then 128, then this is, if you add 32, it will be 160, right? And then so on. Okay. Is this okay to everyone? That's how you are going to access the block numbers. There will be the time that you are also going to access 256, right? Okay. Tell me, are you going to access, let's suppose if I just ask you, okay, let's suppose I ask you, are you going to access this block number 292? Block number 292. Are you going to access this? See, the loop pattern is this, right? Loop is saying that you are going to run for I equal to 0, you are going to run, and j you keep on changing. For I equal to 0, I am asking, okay, whenever I is 0, then j will be 0, j will be 1, and so on, right? And that's why we are having these block numbers. Right now, if I is 1, then also probably this is a0 1, right? Then also you might be having the same access pattern, but don't worry about it. Okay, even for I is 1, we are having the same access pattern, almost same access pattern, but let's not worry about it. I'm just asking access pattern. This is the access pattern when I is 0. Pattern when I is 0. Okay, which means I'm going to access a00, then I'm going to access C. I'm going to access A10, A20, and A30, right? But let's not worry about the indices. I'm just saying that what is the block number you are accessing? 0. And then you got to know that, okay, 32 away. 32 away is the next element. So 32 plus 32 plus 32, you will keep on doing, right? Let me know if that is fine to everyone. If that is fine, let me know. Okay, this is the access pattern. Now, if I ask you that these block numbers are going to map to which line number, then can you tell me? Maybe you can just do mod 120, sorry, mod 256, right? So because the number of lines are 2 power 8, which is 256. These are the number of lines. So you can also tell me the line number, corresponding line number. You can also tell me. Okay, don't worry. Now, suppose if I just ask you randomly whether this block number you are going to access whenever I is 0, what do you think? You can do one thing. You can just see whether 292 is divisible by 32 or not. Since it is not perfectly divisible, tell me, are you going to access this particular block number? No, right? No, because it is not divisible. See, are you going to access 32? Yes, because plus 32 you are doing, right? So for I equal to 0, you are doing plus 32 like that, right? So these are I can say for I equal to 0. Okay, so this is the access pattern for I equal to 0. Now let me just ask you, what is the access pattern for I equal to 1? Can you tell me the access pattern for I equal to 1? You will access this, then you will access this element, right? Whatever this element, then you will access and so on. So what is the access pattern in terms of block number? I think it will be same, isn't it? It will be same. So for I equal to 1 also, it is 0, 32, and 96, 128, and 160, and so on, right? For I equal to 2, will it be same? See, this is 0, 1, then this is 0, 15, right? For I equal to 2, will it be same? Yes. For I equal to 3, will it be same? For I equal to 3, will it be same? Yes. Till what point this will be same? Till what I this will be same? Till I equal to 15, it will be same. And then because this is 0, 15, right? From 0 to 15, it will be same, right? For I equal to 0, and from 0 to 15, it will be same. The moment I is 16, it will be different, right? So you can say that the moment I is 16. So can you tell me the access pattern for I equal to 16? It will be the block number 1, then plus 32 plus 32. Again, everything will be by symmetricity. You are going to access this element, and we are going to access this element, right? So 133 and plus 33 plus 30, sorry, plus 32 plus 32 only, right? So it will be again 32 away. This is plus 32 because 1 here and 33 here. Then which means plus 32. Okay. From these two, you can observe what is the sequence. So plus 32 is what? It will be 95. Okay. So this is 32. This should be 94, right? Okay, sorry. I think here I by mistake I have written this 96. Okay, this will be 65. This will be 65. This is I should have written 64 also. Okay. This is 65 and then 97 and so on. Okay, understood. But anyway, like that much I don't want to go, but I'm just telling you something. Okay, where I'm saying in the cache, if we have 256 lines, so line number 0 will get filled, then 32 will get filled, and then 96 will get filled. Sorry, 64 will get filled. Okay, 32 will get filled, 64 will get filled, then 96 will get filled, 128 will get filled, and 160 will get filled, and till, I mean, few of the lines will get filled basically, right? Few of the lines, okay, will get filled, right? So probably you can also tell me how many lines will get filled. If someone asks you for I equal to 0, how many lines you will fill? So it is 32 to power 3, I think 8 or 9 lines, right? So see, if it is till 64, then you are filling 3 lines, right? So 256 till 256 you are filling 8 plus 1, 9 lines. So you will fill 9 lines, right? If it is like this, because these are the 256. Then it will be keep on repeating. Then 256 plus 32, right? So whatever. So basically again you will go to the line number 0, right? Sorry, line number 32. Line number 32 again you will be going, because this is mod 256. If you take mod 256, you will be getting 32. So maybe 8 or 9 you are filling only. For I equal to 0, see, for this particular total access pattern, this is after 256, will you be accessing? Obviously, yes. See, this array is too big. Okay. See, okay, maybe this question is taking a little longer than I expected. See what I'm saying? You are accessing A00. Then you are accessing A01. Sorry, A10. Right? You are accessing A10. And then you will access A5110 or something, right? So it is, this array is too big. Okay. So you are accessing this block 0, block 32, and then there will be somewhere block 256, which will again map to block 0, I mean line 0. Then you are accessing 256 plus 32. Okay, so let's not worry about the end. Till what point we are accessing. This could be too large number, right? This particular maybe having the block number, maybe if you want to find out the block number will be, can anyone tell me? Maybe 511 into 32. See, this is 1 into 32. This is 0 into 32. That's how you are getting 0. 1 into 32. That's how you are getting 32. The block number. So this is the block number is 511 into 32, which means you will be accessing block 0, block 32, block 32 into 2, block 32 into 3, block 32 into 4, block 32 into 5, till block 32 into 511, because you need to access all the elements. This is for I equal to 0 to maybe 0, for 0 it is same, till I equal to 15 it is same. Is this little bit understood that what I'm trying to say? We don't worry about these numbers. I'm just saying that, okay, the array is too big. However it is big, it doesn't even matter, because this is a mod operation, because the ultimately the cache will be repeating, the lines will be repeating, right? So after 256, you will say, okay, mod 256, it is 0, right? Then 0, then again 32, because 256 plus 32, then again 64, because 256 plus 64, so it will be 64. Is this okay to everyone? That for I equal to 0, this is the access pattern, right? Okay, too much of detail I think we have discussed, but only thing that I wanted to convey at the end of the day, that see, this particular block or any block, if you are going to access this next, which means the moment you access this A01, okay, then which means for I equal to 1, then this particular block has already been replaced. Any of the block will be replaced actually. Is this understood? See, that's the only thing I wanted to convey, that this is repeating, that if this is mapping to 0, then somewhere again you are mapping to 0 in the same iteration, right? Somewhere again you are mapping to 0, which is 256, right? Which is 256. If somewhere again you are mapping to 0, which means you are again going to replace this block number with 256, right? Then again it will be 0, then 0, then 256, then 256 plus 256, then 256 plus 256 plus 256, right? So you will keep on replacing this particular block multiple times, right? This particular block will be keep on replacing. Now the moment you access this next element for I equal to 1, tell me, do you have this block and block number 0 in the cache line 0? No, right? You don't have this, which means it is a miss on every point. Okay, so that's how, like, I mean, this is the similar question that we had earlier, which was a MIT question. So all I'm saying here is that this particular access pattern is so that you are going to, the moment you are going to get this, at that moment you will replace this block, right? So that's why it is 100% miss, because this is how you are going to access. This is block 0, then block 32, and then let's suppose the array is smaller. Let's suppose my access pattern is this much only. Access the block numbers, main memory block numbers are this much. I access the block 32, then 32 into 2, then 32 into 3, then 32 into 4, then 32 into 5, then 32 into 6, right? Then 32 into 7, okay, and 32 into 8. Okay. So let's suppose my access pattern is this much only. I don't have 32 into 8. I don't have 256 again. Okay. If I have 256 line, then am I going to get hit whenever I'm going to access again 0? Which means my array is, instead of having, see, this everything is same, A0 0, A1 0, everything is same, but instead of having A511, okay, this much big, okay, I just have, let's suppose, maybe you can say 7 0, okay, maybe I, in the other dimension I have just 8, okay, 8, maybe the second dimension is same. Now you tell me, will I be missing or hitting when I access this this particular element again? Then I will hit it, right? Because the block I am accessing is 0, 32, 32 into 2. So basically, if you do mod 256, it will be the same number. And then the 256 I don't have. Okay, suppose 256 I don't have. Okay, the block numbers I'm accessing, suppose till 32 into 7. This is the block number 0. This is the block number 32. And then this is the block number 32 into 7. Okay, suppose I have these blocks only, and I mean my array is smaller, not that big array. At that point in time, even though you're accessing this, then this doesn't matter, because everyone is going to different lines, right? Everyone is going to different lines. Then you can see that the moment I access this, it will be hit. And let's suppose that each is containing 16 elements. Then what is the rate here? What is the miss rate? 1 upon 16, right? 1 upon 16. Understood? You can consider this a variation where array sizes you can say 8 5 1 2. Okay, I mean the first dimension is 8. You just have 0 to 7. Okay, in that case basically this is A0 to 15, and then you have multiple other blocks. In that case the miss rate is 1 upon 16, because your access pattern is not too big that you are not replacing this 0 with this 256, right? Understanding my concern that I'm trying to convey? Okay, so basically what is happening here, that your access pattern is basically having this 256. That is why you are replacing this 0 with 250, this, I mean the cache line 0 with 256, then again 256 into 2, then again 256 into 3, and so on, right? So that is why the moment you access for I equal to 1, the moment you access this again, it is already been replaced. That's why it is a miss on every point. So how many elements we have? It is a miss on every element. How many elements we have here? 512 into 512. So that many misses you have. You can see, right? Okay. See, these many total number of misses. So M2 they're asking basically M1 upon M2. M1 we have found out this, M2 is number of miss here, right? So what is the explanation they have given? So they have directly written this. It is so because P1 is okay. For P2, every element there's a miss because storage is row major order by default and we are accessing column. Okay, that's not too good explanation, obviously. I mean, if you have that particular variation that I just told you, which is A8512, do you think this particular line is even valid there? This for this variation, do you have this for every element? Do you have miss? No, right? No. So not valid for this, right? So here miss rate is okay. So this, I mean, even though this is selected as a best answer, but it's not very good explanation, obviously, right? Okay, great. So Satyam, you can post your answer. Trust me, your answer will get very good upvotes. Okay, just write the access pattern, right? Just watch this video. So Satyam is saying, I will post my answer. That's really great. Just watch this video. Write this variation also. Okay. So if this is the variation, then what is the, see, you just need to find out the access pattern of the block numbers, right? If that access pattern is basically, see, this will be the line number for the line number, it is mod 256. If the access pattern is repeating such that mod 256 is giving you 0 again, this is 0 and mod 256 is giving you 0 again, then it means that it is a it will be the miss, right, on the next point, because you are going to replace. Okay, cool. So although they have just written in one line and we have spent half an hour, but that's fine because that explanation was needed, right? Should I explain in short, in maybe 1 or 2 minutes, what I said here? Let me know. See, what I said, there are, you are accessing something, okay? You just need to check that what is the access pattern that you have. You are accessing this element, which is A00. Then you are accessing some element, which is A10. There are, before this, there are how many elements we have? 512 elements. This is having 16 elements. Each block is having 16 elements from A00 to A015. Our access pattern is this, right? Last block that we access is basically A5110. Okay, I mean, for iteration 0, we are going to access this. So we will access block number 0. Then what is the block number for this? 512, which is 2 power 9 upon 2 power 4. Can you tell me the block number? 2 power 5. So this is the block number 32. That is our eureka moment. Eureka moment means that we found out that, okay, this is the pattern. Okay, just with this 2, we can find out the pattern. So now we got to know, okay, this is the pattern. Now, till what point? What is the end point here? Can anyone tell me the end point? We are going to access this. Then what is the end point? End point is 511 into 32. See, what is the block number of this? 0, which means you can say 0 into 32. This is 32, which means 1 into 32. The block number here will be 511 into 32. So this is the end point, right? This is for I equal to 0. We are going to access like this. Now, obviously, the problem here is that after certain point in time, we will be having 256 again. So which means if this is mapping to 0, then this will also map to 0, obviously, right? So since you are clashing, so that's why what is happening here? Since there's a clash, then the moment you access this for I equal to 1, you are again going to have the same pattern, right? For I equal to 1, you are again going to have the same pattern, which means for I equal to 1 also, you will again have the same pattern. This is 0, this is again 0, right? So the moment you access this 0, is this replaced, this block number 0, is this replaced with some other block? That's the only thing that we needed to find out. Tell me, is this replaced? So answer is yes. That's why there's a miss on every point. Okay, there's a miss on every point. And that's how we can solve this question. Okay. Let's now solve this question. This is also quite a good question, which has got 85 upvotes. Okay. Let's just see that how we can solve this question. Now they're saying, consider a machine with a byte addressable main memory, which is having 2 power 16 bytes. Assume that a direct map data cache consists of 32 lines of 64 bytes that are used in the system. Okay. So they are saying that you have main memory size. Generally, it doesn't matter, but I mean, for the misses, it might not matter. But anyway, they've given it. Assume that direct map cache consists of 32 by 32 lines. Okay. Cache size is given 2 power 5 lines. Okay. And line size is given 2 power 6 bytes. There are 50 into 50 two-dimensional array of bytes. Okay. Which means like the size of each element is just 1 byte. Okay. So array size is also given 50 into 50 bytes. They are saying that array is starting from this location. H means hexadecimal. Okay. Array is starting from 1100. Can you tell me this particular location is starting of any block or not? Can you tell me? This 1100 is starting of any block or not? You just need to tell me immediately. This 1100 in hexadecimal, is this starting address of any block? This is block aligned, right? Block aligned. Why? Because last 6 bits, okay, last 6 bits are 0. Okay. So array, they're just saying that array is starting with block aligned. I mean, array is the block aligned. I mean, that's the usual case actually. Okay. That's very interesting. The complete array exists twice. Now assume the data case no change. How many data misses? Okay. Let's just solve this question. This is actually very, very good question. Let's just see if we can solve this question. Okay. So the array, they are saying that it is being accessed but twice. Cool. So let's just write everything on the same page. So now let's just draw the cache. What is the cache? Cache is having 2 power 5 lines. Okay. So there are 32 lines. Right? 0 to 31, or maybe total 32 lines basically. Now they're saying that there are 2500 bytes. Each line is having 2 power 6. Okay. So 50 into 50. So how many lines this array will be having? This is 2 power 6 bytes, right? Which is 64. So you can divide probably 1500 divided by 64, 39 point something, which means 40. Basically 40 blocks it will be spanning, right? Last block may not be containing complete array, right? So 40 blocks basically. I mean, you can say 39 into 64. How much? 2496. Okay. So 2496 bytes are here. Only 4 bytes. 1, 2, 3, 4. 4 elements are here, right? Out of 64 elements, the 4 elements are here. But this is the 40th block, or maybe the block number if you want to write. This is the block number 0, then this is block number 39. Is this okay to everyone? I just looked at that how array look in the main memory. Okay. This is the block number 0. And this is block number 39. Last block may not be containing complete, all the elements are not array elements, but that's fine. Okay, these are the only 4 elements. Now they're saying the array elements are accessed twice. Okay. By the way, for the convenience, I'm writing block 0 and block 39, but the block number, actual block number could be different. The reason is that they have given the address also, 1100. Can you tell me the actual block number? See, this is 16 bits. So can you tell me out of 16 bits, What is the block offset? Block offset is given to you is 6. What is the number of lines? 32 lines, right? 5. So maybe you can take 5 bits here and then you can tell me the block number. Okay. So if you want, I can write the actual block number, but doesn't matter. Okay. If you want, okay, let me write the actual block number. Can you tell me the actual block number? You just see this 1 2 3 0 1 2 3 4 0 then 0 0 0 1. Okay. You keep this 6 aside, then 1 2 3 4. Okay. What is this? What is this number? 2 power 0, 1 and 2. This is 4. So it will be starting from block number 4, right? I mean, the actual block number also you can find out, but that's fine. Okay, maybe if you want, I can write the actual block number also. The block number is basically 4. And since they are going to take 39, total 40 blocks, right? So what is the last block number? I think 39 plus 4, right? 4 plus 39 or something like this. So it is 43, okay, or whatever. So 4 plus 39. I mean, you can write the actual block number also, but that's fine. Okay. So basically, I have a block number 0. I have a block, sorry, not block number 0, the block number 4. Okay. And then some other block number. Then ultimately I have block number 43. Right? Block number 43. This is block number 4. Let me write the actual block numbers if you are interested. These are the block numbers. This is block number 5. Can you tell me the line numbers also? If there are 32 lines, then 4, 5, and then there will be somewhere 0 again, right? 4, 5, 6, and till 31. Till 31 it will be there. The moment it is 32, the block number 32 will be mapping to 0, right? The block number 32 will be mapping to 0. Okay. The block number 31 will be mapping to 31. So basically, you can say this will be mapping to 31. This will be mapping to 0. This will be mapping to 1. And at the last, it will be mapping to something, right? Which is, I think, 12. Okay. At the last, because mod 32 is 12 here. Is this fine, by the way? So 4, 5, 6 till 31 and then 0, 1 to 12. Is this fine? Okay. I think now the question is solved. Okay. The only thing is that you just need to have the mapping. Now they are saying if you access this, the access pattern is very, very simple. Okay. So they are saying that, see, this part should be done. If this part is done, then you can do the remaining part. Okay. These are 32 lines we have here. These are 32 lines. You tell me if something is mapping to line number 4, doesn't matter wherever it is. Okay. Suppose this is line number 4. If something is mapping to line number 4, then 4, 5, 6, 7, like this, then till 31. Till 31 you are mapping, and then again to 0, 2, 1, 2, 3, 4. But again, you will replace this line number 4, right? So someone will replace the line number 4. Is this fine? Let me know. Okay, maybe I can go to the next page. Okay, see. Can you tell me the block numbers? The block number, this 4 will be, this line number 4 will be having the block number 4, right? Then this is 5. Then basically, this is, let's suppose, cache. Okay. These are the block numbers I'm writing. These are the line numbers. Okay. This is 4, 5, and then till block number 31 will mapping here. Block number 32 will map here, right? Block number 33 will map here. 34 will map here. 35 will map here. Now we have 43 blocks. That is why 36 will map here. And the moment you access 36, you will replace the block number 4. Is this fine? See, 4, 5, 6, these are the earlier blocks, right? 4, 5, 6, 7. That's how you map 6, 7, 8, 9, 10, 11, 12, and so on, right? But 36 will replace, I mean, this block number 4 will map here, 5, 6 is 31, 32, 35, 36 will again map to the line number 4. So it will replace the previous line. 37 will replace here, 38 will replace here, 39 will replace this, 40 will replace this, 41 will replace this, 42 will replace this, 43 will replace this, right? Is this fine? Because 43 will be also mapping to 11, right? Okay. So after one iteration, you are having 32 to 43 and maybe 12 to 31. Okay, after one iteration. Is this fine? Now, if you have one more iteration, see at the first iteration, how many misses you have? How many miss you have at the first iteration? Each block will be just one miss, right? So I think 43 miss. So you are going to have, sorry, how many blocks you have here? How many blocks these are? 39, right? Okay. No, you have 40 blocks or sorry, so you have total 40 blocks, right? So total 40 blocks you have. So for every block, there will be just one miss at the first iteration, right? So this is number of misses in first iteration. Right? In the first iteration, you have these many misses. And this is how your cache look like after first iteration. Okay, this is how your cache look after first iteration. Now during second iteration, this 4 will be miss. This 4 to actually 11 will be miss, right? These will be miss. These will miss. So during second iteration, this 12 to you can say 12 to again this 31 and then 32 till 35 it will be hit. But how many misses will be there? This will be 1, 2, 3, 4, 5, 6, 7, 8. 8 misses will be there, right? So 8 misses will be there. 8, I mean, to start with, there will be 8 misses. Starting 8 blocks will be miss. Then everything is there, but the end 8 blocks will also be miss, right? Because this will be replaced. So end 8 blocks also miss. So this is misses in second iteration. Getting? So it will be 56 misses. Oh my God, 256 upvotes. I think this is one of the highest upvote that any of the answer might be having. But yeah, option C is the answer. C is 56 misses. Okay, maybe I can solve this again. See, here, let's just first understand what I'm saying. That for first iteration, all 40 is miss. For second iteration, I'm saying that these, like to start with, these 8 will be misses, but everything is hit. Then last 8 will also be missed, right? Because you will be replacing them with 4, 5, 6. Then you again have to replace with 36, and so on, right? So last 8 will be again missed. First 8 and last 8 also. So after second iteration, how does the cache look like? Exactly same, right? After second iteration also, cache will also look like exactly same. Because this will get replaced with 4, 5. Then again, at the last, it will get replaced with 36, 37 like this, right? So after second iteration also, it will look like this. The cache will look like this. Okay. So what I'm saying, see, let's not worry about the block number 4 and all. See, there are 40 blocks. Okay. Suppose this is, I'm just writing block number 0. Okay. Just to make you understand. Let's suppose this is the block number 0 only. 0 to 39. Okay. How many lines we have? How many lines we have? 32 lines. Okay. Easy only. This question is not very tough, just easy only. You just see here, this will be mapping to, this is having 0 to 32 or 31, I mean 0 to 31. Then obviously we have 32. This 0 will get replaced with 32, 33, 34, 35, 36 till 39, right? So basically initial, how many? 39 minus 32 is 7. Initial 8 will be replaced, right? Is this okay to everyone? See, 0 to 31 will be like this, and then 32 to 39 will replace initial 8. Is this okay? I mean, in the actual thing, we are starting from middle, but that's fine. It is a modulo operation. It will be repeating. Okay. So I am saying that initial 8, you just fill 0 to 31, and then 32 to 39 will be replacing this much. So how many miss you have? Obviously, the 40 miss you have in the first iteration. But then in the next iteration, this will again be replaced with 0 to 7, right? I mean, 0 to 7 will be having miss, but everything is hit. So 8 misses, everything is hit. Then again, last 32 will be also missed, 32 to 39. So again, 8 more. Understanding? See, with this diagram, you should understand that what I'm trying to say. Here, don't worry about the, for now, don't worry about the actual numbers. Okay, just understand the concept. You have total these 40 blocks. You have 32 lines, right? The only question they're asking, easy question only, the only question they're asking, if you access all of these blocks twice, then what are the total number of misses? Okay, so these are the 32 lines. Very, very easy question. These are the 40 blocks. What is the question they're asking? Let me write the question also in the naive term. If you access all blocks twice, then what is number of misses in total? Understood the question? Okay. So can you tell me, if you access all of this twice, then what is the number of misses in total? How many miss you will be having? In the first iteration, how many miss you will be having? If these are the 40 blocks, 40 miss, right? All 40 miss in first iteration. In the next iteration, what you will be having? That is more interesting. So in the next iteration, you will be basically, I mean, initially it was 0, the block number 0 to 31, and then 32 will be replacing this. Then maybe you have till 39 will be block number 39 will be replacing something, and then probably you will be having the usual numberings, right? Which is basically, okay, so basically this is G, I think from 8, right? From 8, it will be anyway the usual 8, 9, 10. It will be having 8 to 31 anyway. It has, right? So in the second iteration, it will be basically saying, okay, from 0 to 7, I haven't found. So that's why 7 miss. Everything else I have found, but last 32 to 39, sorry, 8 miss. 0 to 7, I have not found. So 8 miss. So everything I have found, but last 32 to 39, still that is not there because I just replaced it. So again, 8 miss, right? So that's how you can solve this question. This is in second iteration. Tell me, if I ask the same question in this naive language, can you answer this question? That 40 blocks in the main memory, 32 blocks in the cache. If you access all the blocks twice, then how many misses you have, right? That's what they're asking. I hope you can answer that question. Okay. And you can see the gravity of this question. It is having 279 upvotes, which is, I think, too much, right? And that too for this kind of question, which means that too for the question which is not very interesting to the people, right? Generally, these kind of question people doesn't solve. They just say that, okay, we will not solve. We will not practice these questions. For these kind of questions, still, if there are 279 upvotes, it is too much. Okay. Yes, if you just do it calmly, then I think you can do it, right? Yeah, obviously, this is a good question. This is a hard question. I'm not saying it is an easy question, but it is doable. Okay, it is doable. That's the only thing I'm saying. Obviously, from this upwards, you can see that it is not easy question. Must be hard, and it is doable, but right. In actual numbering, if they're calling this line or the block 0 as a0, then actual numbering, this a0 is mapping to 4, then like this, then these will get replaced, right? These will get replaced. Okay. So this is the actual numbering, actual mapping. Okay. Now actually they have asked two questions, okay, in the same year. This is the next part. Now they are saying that in the second question, they are saying only this line is different. Which of the following lines of the data cache will be replaced by the new blocks in accessing the array of second time? So new blocks. So which of the following data cache will be replaced? Okay. So which lines will be replaced by new blocks? See, everything will not get replaced. These will get replaced, right? These will get replaced with A0 to A7 again, and then again A32 to like this. So which are going to get replaced? I think the line number 4 to line number 11, right? So I think A is the correct answer here. Yeah, so A is the answer. It is not written, but yeah, A is the answer. Okay, 4 to 11 was replaced. So this question has been asking get 2007. Okay. Now let's just do this question. This question is, I think, quite easy question only. Let's just try. Okay. Do you want to try this question as an homework? Let me know. So okay. So maybe you can try this question as an homework, because this is very, very easy question. In fact, you can do it now also. It is so easy that you should be able to do within 2-3 minutes only. Okay. Consider a machine that is having 2-way set associative data cache of size 64 bytes, 64 KB. Okay. So cache size is 64 KB, which means 2 power 16 bytes. And the block size is 2 power 4 bytes, right? Virtual address size is given. I don't think it is needed for this question. The size of the double is 8 bytes. Okay. Element size is 8 bytes. It means 2 power 4 upon 2 power 3. It means 2 elements, right? 2 elements. Each block can have just 2 elements. Array is located at the beginning of some virtual page this much. So can you tell me, is this the block aligned? Is this the array is starting at some block, starting of the block? This is the starting address of the block or not? Tell me. The block size is 2 power 4. Since it is 2 power 4, that is why you can say that it is definitely like this is 4 bits at 0. So it is definitely the starting address of a block, right? Okay. Cache is initially empty and no prefetching is done. The only data memory reference are the array, the hit ratio they're asking. Okay. This is IJ. So array is basically 2 power 10 into 2 power 10 elements. Each block is having how many elements? 2 elements, right? So this is 1 block, 2 block. There are many, many blocks that you will have. Okay. This is, let's suppose, okay, actual block number, it doesn't matter unless and until they ask. See, they ask here they ask basically something related to actual block number, then only it mattered. Otherwise it doesn't matter because of cyclic nature. Okay, so I'm not going to find out the actual block number using this address. Let's suppose this is block number 0. This will be the block number 1 and block number 2. If this is containing 2 elements, okay, then you just need to tell me that they're just accessing the array elements once. So whether this will be hit or miss, what do you think? For the first element it is miss, and then for the next element it will be hit, right? It will be hit. So since they're just accessing it one time, then it doesn't even matter that what is the cache size, whatever. Okay, whatever it is. Okay, I don't care. So it is miss and hit. It is miss and hit. Will this pattern anyway change because of the cache size, because of anything else? No, right? If the block size is same, I'm not saying the block size is different. If the block size is same, the cache size and these things, and it is direct mapped or whatever mapped it is, and will this matter? 2-way set associative and so on. Tell me. Miss and hit, right? Miss hit. It won't change. So 1/2, right? 1/2. Understood? Even if it's direct map, 2-way set associative, these things won't matter for this particular question. Okay. But yeah, suppose the block size they are increasing. Suppose the block size they have the block size to be, let's suppose, 4 elements. Then can you tell me the miss rate? If the block size is 4 elements, 2-way or 3-way or whatever way, doesn't matter, right? If block size is 4 elements, then can you tell me the miss rate quickly? 1/4. Yes, 1/4, right? It is just one miss. So if they increase the block size, then yes, it matter. Cache size, the mapping, whether it's 2-way, 4-way, 8-way, direct map, fully associative, these things won't matter, right? So you can say as a variation. So here, if cache size is increased or decreased, keeping block size same, right? Keeping block size same, then also answer is same. But if the block size is suppose 4 elements, then the miss rate is 1/4. Okay. Understood? Okay. So it was easy question. Now, because we have solved so many good questions, now it will be very easy question. See, when I was solving at my time, even I have taken maybe 1 or 2 hours just to solve this question, that how we are solving and how we are not solving, right? But now it is very straightforward question to you guys, right? See, the actual block number actually doesn't matter because of the cyclic nature. Like whatever is the block number, it won't matter actually, right? Maybe it is starting from block number 0, maybe block number 10 or block number 20. It won't matter. Okay, it will be just incrementing, and that at certain point in time, it will be again 0. Okay. Let's now see this question. So what they're saying, in a C program, an array is declared as float and then 4 byte, and then starting address is this. The program is run on the computer that has direct map cache with the block size this. Which array element conflict with the A0 in the data cache? Okay. So do you want to solve this? So what they're saying, that you have 2 power 11, right? 2 power 11 is the number of elements, and each array element is 4 byte size. Okay. And the direct mapped data cache is used, which is 2 power 13 bytes, and the block size is 2 power 4. So which means how many elements actually? 4 elements, right? Each block is having 4 elements. Each block is having 4 elements, right? What is the size of the cache? 2 power 13 bytes, or maybe you can say divide by 2 power 4, which means how many 2 power 9 lines you have, right? 2 power 9 lines you have. Okay. So you have 2 power 9 lines. And array will be containing how many lines? 2 power 11 elements. Each element can contain 4. Each line can contain 4 lines. So I think 2 power 11 upon 2 power 2. 2 power 9. Yeah, array will also contain 2 power 9 lines. Okay, that's interesting. So they are saying that there is an array which is basically contain 2 power. I mean that is going to be that is going to consume 2 power 9 blocks. Okay, and then this is your cache, which is also having 2 power 9 blocks. Okay. It doesn't matter what is the initial block number. Maybe it has stored, the initial block has stored at the block number 5 or block number 10, or doesn't matter. See, whatever the block it is mapping, can you tell me this A0, okay, is this getting clashed with anything else? What do you think? Will it get clashed with anything else? Is your array too big that you have to repeat it? Array is having 2 power 9 blocks. So let's suppose it is mapping. Initially, it is mapping to block number 0. Then this is A0. If it is mapping to block number 0, then it will map to the last block, because these are the 2 power 9 blocks. These arrays also containing 2 power 9 blocks. So it is not going to clash with anyone, because sizes are same actually. That's why it is not going to clash with anyone. Understood? So here I can say what is the answer? So no collision, right? Understood? Okay. If the array size is, let's suppose, bigger, suppose if I say there is one more block means each block is containing 4 elements. So maybe let's suppose 4 elements. So basically instead of 2048, if I have these many elements of the array, then will it be clash? If there is one more, even if there is one more, will it be clash? Yes. Suppose there is one more, but this is not mapped to 0. Let's suppose this is mapped to someone. I mean, this is the block number, maybe 15. Okay, it is mapped to, let's suppose, 15. Will it be clash? Now it will again clash, right? It doesn't matter. The initial block number doesn't matter. 15 to then it will be repeating, right? Somewhere it will be 0. So this absolute number doesn't matter. Then 1 to 14, then it will be 15 again, right? Because this is 2 power 9. So basically, even though this is a cycle, even though you start filling from here, okay, some block here, 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 then ultimately you will filling, then the extra block will get remaining. That will map to this only. A0 will get clash. A0 will still get clash. Understanding my point? Even though the initial block number actually doesn't matter, even though this is 15 or 20 or anything, so you will start feeling like this, and these are 2 power 9 blocks, but you have one more block. Since you have one more block, it will be again clashing with A0 only, not anything else, right? It will be clashing with A0 only. Understood? Okay, so currently there is no clash because no collision or no conflict or whatever you want to say, because array size is same as cache size. That's the reason, right? Okay. Now what they're saying, if the program access this array one by one in the reverse order, okay, if you're accessing in the reverse order, starting with the last element, and then how many data cache misses would occur? Justify your answer. Assume the data cache is initially empty and no other instruction. Okay, I don't think it will matter, but yeah, if you access in the how many blocks we have here, I think 2 power 9 blocks. So how many misses will occur? 2 power 9 misses, right? For every block there is a miss. You access from here or you access from here, doesn't matter. So how many meshes will be there? 2 power 9, because 2 power 9 blocks are here. So every block will be just miss. Okay, the first element will be miss, and then these are the hit. So 2 power 9 meshes will be there, right? 512 cache mesh. Understood? Okay. Yeah, these two questions are independent only. Like A and B part are independent. Okay. Easy question only. I hope you understood. Cool. Okay. Do you want to try this question as an homework? This is a little nice question. You can try as an homework. Okay. Yeah, this is a good question. Do you first want to try or I should solve it directly? Okay, maybe I can solve this question, right? Maybe I can just give you some hint and then you can try now and then we can solve this question. So let's just see this, what they're saying. Consider a machine which is two-way set associative, data cache of size 64 KB. So the cache size is given to you is 2 power 16 bytes. The block size is given to you is 2 power 4 bytes. So how many blocks you have here? 2 power 12 blocks, which means if it is two-way set associative, 2 power, how many sets we have? 10 or 11? 2 power 11, right? 2 power 11 sets. Okay. The cache is managed using 32-bit virtual address and the page size is 4 KB. This is so on. The size of the double is 8 bytes. Okay. So element size is given. Basically, you can say the element of array is having 8 bytes. So each block will be containing how many elements? 2 elements only, right? 2 elements. 32-bit is complete address. So if this is 32-bit, can you tell me what is the block offset? 4. What is the number of sets? 11. So this is tag, right? What is the tag? 11 and 4, 15. So 17 is tag. This is tag. This is set index. This is block offset. Which of the following array element have the same cache index as this? Okay. So they are saying that array is getting stored at this 0xFF000. Okay. So, so let's just go to the next page. Okay. So this is basically double F triple zero is your initial address of the array. I can make some space, right? Okay. So let's just now solve it. See, 0x FF000. Okay. So FF000 is your base address of the array. FF000 in the hexadecimal, obviously. Now they are saying that which of the following array element have the cache index which is same as A00. So A00 address is this one, right? A00 address is this one. Now, if you want to have same cache index, then what you have to do? Basically, you need to tell me the address of this, and then you can check whether it is having the same cache index or not. So this is basically, if I just tell you that this is the array index, this is address, then can you tell me the address of A01? Then you need to add one element. One element size is 8 bytes. So you need to add plus 2 power 3 here, right? So plus 2 power 3 is basically the next address, right? If it is 01. For 04, how much you need to add? Plus, how much you need to add? Plus 2 power 3 into 4. So see, if it is 1, then plus 2 power 3. For 04 plus 2 power 3 into 4, which means plus you need to basically add with the starting address, you need to add 2 power 5, right? 2 power 5. Okay. Is this fine to everyone? Now, if you add 2 power 5, which means 1 followed by 5 zeros, will it be having same cache index, same set index? Tell me. See, if you add 1 followed by 5 zeros, won't the index will be changing? Aren't you changing something here? You are changing, right? So that's why this is not the answer. If you add plus 2 power 5, that's not the answer. What about this 40? Okay. Now, this array is basically, dimension is how much? Okay, 2 power 10 into 2 power 10. This is A00 till A0 1, and then this is 2 power 10, which is 1023, right? 1024 minus 1. Okay. So this is basically A0, then A1, and so on. Okay. How many elements you have here? 1024 elements, right? If it is A1 something, A10, then 1024 elements. Now, if it is A40, how many elements you have before A40? How many elements you have before A40? 1024 into 4 elements, right? So if you, let's suppose this is before this, there is one element, right? Then you add, I mean, you say that, okay, plus 1 basically. So here you will say that this is 2 power 10 into 2 power 2, which is 2 power 12, right? 2 power 12 elements you have before. So how many bytes you have? 2 power 12 into, what is the size of each element? 8, right? So 2 power 12 elements you have before. So you need to add basically 2 power 12 elements, and then each element is having 8 bytes. So 2 power 15 you need to add. 1 followed by 15 zeros. What do you think? Will it be having the same index? 1 followed by 15 zeros. I think yes, right? I think yes. So this is the answer. But let's just see more. You can see here, it will be how much you need to add. Basically, you will be disturbing something here. See, until and unless you add 1 followed by 1 followed by 15 zero. This is the very first element which is having the same index as that one, right? As A00. Because at least you have to add 1 followed by 5 zeros, right? This is the very first number. Then by the symmetricity, you can say that it will be again after so many elements, not after just maybe a 80 will be having the same set index, right? Not 50. So that's why B is the correct answer here. Understood? You just need to check the addresses, basically how much you need to add. So that's how you can solve this question. What is the answer? Yeah, B is the correct answer, right? Okay, you just need to check. See, once you got to know that, okay, 1 followed by 15 zeros you need to add, and then if this is the answer, even if this is MSQ, you can, by symmetricity, you can assume, or you can say that this is not the answer, because if A00 is there and after that so many elements which is A40, that means after A80 only will be sharing that, right? A80, not something like at this. Okay, so B is the answer here. You can check with the addresses and then you can solve this question. Okay, so these are all the questions that we have in the PYQ. I think one question I have not solved. Okay, so yeah, only one question I haven't solved. You just try this question as a number. This is a good question. I want you to solve. Okay, just try your best and see if you are able to solve this question. This is a very good question. Okay, cool. So I think we have solved all the PYQs here. And it was really a nice session in the sense that just to do all of these, I have taken, if I've taken 8 to 10 days, then I think these 2 hours are worth, right? Now, if you, let's suppose, want to do more practice of the same kind of question, then even more tricky questions are there. This is just optional practice questions that I have. Okay, so you can see this question, you can see the answer on the next page, you can solve this question, answer is on the next page, solve this question, answer is on the next page, solve this question, answer is on the next page, and so on. Okay, there are 7-8 questions that I have put in, but these are little tricky questions. Okay, if you want, you can try out. Otherwise, this is just optional practice. Okay, this is optional practice question. Cool. See, in all the questions, you just need to be little focused. That's all. Okay, it's not like that these questions are too tough. You just try all of these questions again at your home, and then see if you're able to solve. Okay, cool. So that is all. There are a few other questions, like 1-2 other questions that I have kept here. If you want, we can solve. Otherwise, you can also solve them as a homework. Maybe let's just try this question. Okay. So what they're saying, address ABC. There are 3 addresses that have the same index. A and B have the same tag and C is different. Okay, this is a direct map cache. So they are saying ABC has the same index, which means this is mapping to, let's suppose, line number 3. This is also mapping to line number 3. This is also mapping to line number 3. A and B have the same tag. Okay, so in the line number 3, there will be tag, right? So A and B even are sharing the same tag. So the tag is same here. And C tag is different. Okay, B and C have the same block offset. Okay, actually it won't matter much, the block offset, but yeah, they are having the same block offset. But age block offset is different. Starting with the, how many hits we have? Okay, so how many hit we have? See, yeah, A and B are basically these are the 2 addresses. Yes, Satyam is saying very nice point. If the tag and index, see, index of everything is same. If the tag and index is same in the direct map, tag and index, what did it tell you? The block number, right? The block number of A and B must be same. So this is the same block. This is also some element from the same block, right? Now they are saying how many hit we have here. If you're generating A, then initially it is miss, right? Initially it is miss. Then on B will be having hit or miss? Tell me, are we having that particular block in the cache? Yes, right? We have that particular block in the cache. So, I mean, within that block, there is some A. I mean, A is actually this particular address. And within that block, B could be some different address, but the block number is same. So if A is missed, then B will be hit. C will replace that particular block, right? Because that block is different. So C is again miss. And it will even replace. And what about this A? Can anyone tell me? It will be again miss because C has replaced it. And what about this B? It is hit. So basically, after A, if B is coming, then it is hit actually, right? If in between, if C is coming, it will create a problem. So what is the answer? How many hit we have? I think 2 hit, because after A, B is coming 2 times. I mean, 2 hits we have, right? Yeah, E is the answer here, right? Easy question only. So I have taken this question, and there is one more question that you can try as an homework. This is also easy question. Okay. So we have solved all the tricky questions that we have here in the GATE PYQs. And I hope you understood all of the questions. I will just say that you just need to solve them once more. It's the nature of the problem, that nature of these questions, that it may look little tricky, little scary, but if you solve them one more time, then you will get the confidence, right? Okay. Now, are you ready to solve the recent question, GATE 2023 question, which is also with the same pattern? Should we solve this? So that question actually not from computer organization, that was related to a bit related to operating system. So if you want, I can put that question here so you can solve it later on. Okay. If you have seen OS, then you can definitely solve that question also. So maybe I can put it after this. This is GATE 2023 question. This question is also related to the same concepts, and they are asking about the page faults. Okay. So this is related to LRU scheme, so which we have covered in OS. If you want, you can try out this question, right? You can try out this question, and then you can see that if you're able to solve this question. Okay. So that is all. And now, as you can see that I have categorized these type of list. So this is done. This is done. There are few questions that we need to do with respect to effective access time. We will do it. And then there are 1 or 2 questions of some other techniques. We will also do that. Okay. So in the next session, we will most probably do all of these effective access time type of questions, right? Okay. The most trickiest one is this. And like these are the easiest one I can say, but very, very necessary to understand the basics of this cache. Okay. Cool. So we will solve these kind of questions also. Yeah. Thank you, everyone. Take care. Bye-bye.